Hi everyone. In this video, we are going to talk about a statement and the Euler diagram. First of all, statement. This is definition of a statement, which is a declarative sentence that is either true or false. That means you make the declaration, and that declaration can only be true or false, cannot be anything else. In other words, it can only have two logical values, either true or false. Let's look at some examples of statements. The first one, the earth is round. So actually, it doesn't matter we know that the earth is round or not. The truth is that there's only two possible outcomes for this sentence. If it actually is round, that means this statement is true. If actually Earth is not round, then this sentence is false. And that's why it is considered to be a statement, because the value of this sentence can only be true or false, cannot be something else. Second one, the earth is flat. Basically, it's the same as the first one. And the truth is there. It is either flat or not flat. So as a result, this sentence can only be true or false, one of those two. The third one, the earth is not round. Even though this is a negation of the first one, in terms of being a statement, there's no difference, because the outcome of this sentence, the earth is not round, can only be one of the two. Either it is true or it is false, no other possibilities. The fourth one, and there are aliens on the Mars. Well, that's interesting. Do we know, are we sure that there are aliens on Mars? Actually, it doesn't matter. We don't care. If they are aliens on Mars, then this sentence is true. If they are not aliens on the Mars, then this sentence is false. Again, the outcome can only be true and false. That's what makes it a statement. So all of these four are the examples of statement. Now let's look at two examples that are not a statement, so that at least you have some comparison, right? So look at these two examples. The first one, is Jack a gateway student? Well, this is question, right? Question cannot become a statement. The reason is a statement has to be something like a declaration. This is not declaration. This is a question, so it is not a statement. Now, second one, the most beautiful color is the red color. So now, this sounds like a declaration. Actually, the outcome of this sentence is not clear. The reason is this word beautiful. Beautiful is a subjective word. It's a person's opinion. Some people think a red color is the most beautiful one, but many other people don't think so. So in other words, this is a purely opinion. It's not factual. Say, unlike one of those four examples we mentioned above, say, for example, the fourth one, there are aliens on the Mars. On the Mars? Say, we don't know if there are aliens on the Mars or not, but it doesn't matter. Either they are on the Mars or they are not. It's going to be factual. It's not people's opinion. This is beautiful. This word is people's opinion. So this one cannot be a statement. Okay, let's move on to the next topic. In the next topic, we are going to look at how to negate a statement. That means how to create a negation of a statement. Now, in general, there are two different ways to negate a statement. Actually, it's a very straightforward, both of them. The first one, you can negate the verb in the original statement in order to negate the whole thing. Or you can use this structure to negate the original statement. you're going to say it is not true that, then you follow that by the original statement. So it is not true that original statement. Now let's look at some examples to see how to use these two different methods to negate a statement. So the first one, here it is, actually on the previous page. This is our first example. And this is the original statement. Jack is a gateway student. Now we want to negate this statement. First method is that we do that by negate the verb in this statement. So is a word, is a verb. And negation of that is not, right? So this is negation. Jack is not a gateway student. So we just negate that. Or and put it is not true that this part in front of this original statement. That's another way to make negation. Say it is not true that Jack is a gateway student. Just different way to negate a statement. In other words, we don't really care the original statement true or not. If this is true, this is going to be opposite of that. If this is not true, then this is the opposite of that. Always get the original. Okay, now there's another one. It is an exercise problem. So if this is the face-to-face class, this one is for students to do the exercise. But I'm going to do this as an example. Negate the following sentence using two methods. Actually, this is a statement. You can say sentence, but we'd rather say statement. It's more accurate. Statement. So the statement is Jack studied very hard for the last history test. So now we are going to negate this two using two methods. The first method, which is negate the verb, right? The verb in this case is study. So Jack didn't study hard for the last chemistry test. Yeah, we negate it. Now method two. We use that structure, right? It is not true, that structure. So it is not true that copy the original statement. Jack studied very hard for the last chemistry test. Yeah, that's how we negate a statement. Now, next topic is about quantified statements. So what is a quantified statement? Basically, when you put one of these words, such as all, every, none, or some others like some, one, at least one, these quantifiers in front of a statement, and that statement becomes quantified statements. Okay. Now, some examples of quantified statements. All Icelandic children learn English in school. All, that means no exception. That's quantified, all of them, every single one of them. Another one, some gateway students received scholarships last semester. So this is quantified. Some here actually is equivalent to at least one. You can use this two exchangeably. At least one. means some, at least one, maybe more than one, maybe all of them. All of them is part of at least one. It's no limit, upper limit. Just this is the bottom limit, basically, at least one or more. Okay, now next, we are going to learn just through examples. We are going to learn 4 relationships. No, I'm going to take that back. I'm going to learn how to negate a quantified statement. Basically, we have 4 basic structures for the original statement with quantifiers in front of them. Then we look at how to negate each one of them. This is just generally list all of these possible statements and then how to negate them. For example, if your original statement is all A are B, then the negation of that will be at least one A that is not B. So now we are going to go over this negations of quantified statement one by one through the examples. So the first one, or how to negate all A or B. This is the original statement. This is in general. Or specific example is this: all students in this classroom are male. Like all A means students in this classroom, B is male. All A are B. Now, in terms of structure, we can visualize this original statement. Whenever you visualize it, it's much easier to draw a conclusion. Let's do that. So treat this A and B like two sets. All A are B. That means everything in A is also in B. You will draw it this way. So suppose this is B, and this is A. Apparently, all A are B. Anything in A is also in B, all A are B. And that's this structure. Now, how do we negate this? We negate this actually by moving these 2 circles in a way that will result in that not all of A are in B anymore. In other words, after you move it, you cannot claim all A are B anymore. That means we negate that. So look at how I move them. Since now A is entirely in B, which is original, I'm going to change that. So I'm going to change that to this is B. Now this is A. You see that? This is A. Now, since there's a tiny bit of A that come outside B, you cannot claim all A are B anymore. So that means if you say all A are B, that's wrong. That's negation because you have this part that is not in B. That means this part negates this whole thing. It's not this part of A. This part of A is still in B. But this part is not in B. You can, as soon as you have this tiny part of A coming out of B, you cannot claim all A are B anymore. You negate that. So this small part means at least one. If you have at least one in here that is outside B, then you cannot say all A are in B anymore. That means negation of all A are B is some A are not B. That's not B. Some A are not B. So how do we do that? All students in this classroom are male. This like all students, this like male. So this is some students are not in male circle. Some students are not male. So the result, at least one student in the classroom is not male. At least one is the same as some. That's why I say or. Some students in the classroom are not male. Some students in the classroom are not male. These 2 are equivalent. So you can negate this easily by using the relative location of these 2 sides. To negate the original statement, you want to change it in a way so that original, the structure is not true anymore. Okay, next one. So this one, basically negation is a sum A or not B. Sum A or not B. Now let's look at the second one. And we're going to look at how to negate no A or B. First, we represent them. We represent this original. This is A, this B. They are not connected. They are not overlapped. So apparently anything in A is not in B. So no A or B. That's original. If you want to change this relation, you have to move this circle in a way so that they overlap each other. As long as they're not overlapping, this is still original, no A or B, right? You need to change so that they overlap. You change it as soon as they overlap just a little bit, it will change this is the original statement. This is A, this is B. So this part of A make this untrue anymore, because you cannot claim no A or B, because this part of A is in B now. You don't have to move A entirely into B for this original statement to be false. You just move it enough so that this one is false. So how to describe this part? This is sum of A, right? Sum of A are in B now. So the negation of no A or B is some A or B, or at least one A or B. Either way is okay. So I'm going to say some A or B. That's negation. Some A or B. Now let's look at this particular example. No students in the classroom are male. So look at the structure. Then some students in the classroom are male. So some students in the classroom are male, or at least one student in the classroom is male. That's the same thing. Now, third one, how to negate at least one A is B. That's the original. That means whenever you have at least or some, that means they have overlap. This A, this B. This original at least one A in B, they refer to this part. At least some of it is in B. At least there's one in here, in B. That's called at least one A in B. Now, if you want to change this, how do you change that so that it's not true anymore? If you move it so that this A and B overlap more, such as this one, if they overlap more, this is still consistent with the original statement, because in this situation, you can still claim some A are in B, at least one in A that is in B, right? That's the original statement. This is not negation. So this is not the answer. Instead, this will move towards each other so that they overlap more. Now, since this one doesn't work, you move these two away from each other. So the result is this. Now, the original one says at least one A is B. Now you can, in this case, you cannot claim that because this is not at least one in B anymore. No A in B. So the negation of this is this. So no A or B. This is the negation. Just read it. This means no A or B. So look at the specific one particular example. At least one student in the classroom is male. So at least one is male. This is a student. This is the male. At least one is male. Then the negation is one. No student in the classroom is male. So no student in the classroom are male. That's the negation. There's no other way to say this. So example 4, how to negate at least one A that is not B. This is pretty much like the third one. Whenever you have some or at least, you draw two circles with some area overlap. So this is A, this B. They are talking about at least one A. Some A is not B. You have to be outside B to be not B, right? They refer to this part this time. some A, at least one A that is not B. And this one means some A are B. This means some A are not B. This is original. In order to make this untrue, how do we move this circle? Think about that. They emphasize that there's something outside B. If you want to make this untrue, you have to make this something outside B go away. The only way to do that is you move this A entirely inside B. This way you cannot claim some A are not B because all A are B now. This part is gone. So some A, that means all A are B. That's negation. All A are B. Now let's look at this particular one. At least one student in the classroom is not male. So this is a classroom. Then it's classroom. This is the male. They're talking about here. At least one student in the classroom are not male. So negation is all A are B. All students in the classroom are male. So that's negation. Okay, now this is some exercise. So let's skip this page. Basically, it's very similar to the one that we just did. Let's move on to the next topic. This one is about the Euler diagram. And actually, Euler diagram is very simple, very similar to the Venn diagrams. In Venn diagrams, you have circles inside the rectangle. And for Euler diagram, we also have circles inside a rectangle. In this course, we only deal with this kind of structure that you have one rectangle to represent the universal set and two circles to represent two individual sets. Even though we could have more than two sets, but we don't deal with that in this class, in this course. So we only have one rectangle and two circles, two sets. Now, in Euler diagram, we don't need to fill each different region with elements, just like what we do in the Venn diagram. So we only have rectangle and two circles. What more important in Euler diagram is the relation between those two sides, and there's only 4 of those. And I'm going to show you all of this. There's only 4 when it comes to two circles. So first, all A are B. That means one circle is entirely inside the other one. This is the most important part. Once you get this part, you can solve all of the Euler related problems. This is like models. We have 4 basic models. All A are B. That means A is entirely in B. I'm just drawing these circles because there are always a rectangle surround all of the circles. I assume everybody knows that, so I just draw the circles. This is B, this is A. That's how you represent this relation. All A are B. All A are B. Everything in A is also in B automatically. So second relation between set A and set B, some A are B. Whenever you see some, it represents overlap region. So that means the 2 circles overlap partially. So if this is A, this is B, they refer this part. Some of A are in B, some A are B. So that's the second representation, the relation between these 2 sides. Third one, no A are B. I think most of you already guessed. This is A, this is this is B. This is supposed to be a circle. This is the B. See, they don't touch each other. No element in A are in B. So no A are B. They're totally separated. Okay, move on. Look at the number 4. Some A are not B. So we still have some. That means we still have partially overlapped circles. We still have this, A and B. But this time, the focus is not this part. This part, some A are B. This one says some A are not B. So they are emphasize this portion of A instead of this portion. Some A are not B. This part is A is outside B. So that's all we have for this relation between two circles. Once you understand how to represent a statement, one of the four statements using the circles, the rest are very, very easy to do. So I'm going to have this example, which is from your homework. I pulled it out from your homework pool. I don't know if you're going to see this exact one or not, but your homework should be very similar to this. Now, here is how to do this problem. Match each diagram with its meaning. Now, these are the diagrams. This is just like a legend to tell you which one is which. So here we use a blue circle and to represent the windy, people who like windy, actually, windy days, people who like windy days. And this red circle represents people who live in Chicago. Okay, that's the two different sides. Now you have four different statements. You're going to match each of these statements with one of the four diagrams, four Euler diagrams. We have two in here, we have two on the next page. So let's do it one by one. Let's look at this one. This diagram says blue circle is entirely inside the red circle, right? So you translate that into one of our four models. This means this. All, this is a blue circle. I just use blue. All blue are red. Basically, that's our model. But try to match this with one of this statement. You have to start with all, right? Blue is windy. People who love windy days. So if you match this with these two basic sides, all people who love windy days are living in Chicago, are red. Red means people live Chicago. Let's say which one is our answer. It has to start with something like all. Everyone means all. Everyone that likes windy days, that's blue. Everyone that likes windy days lives in Chicago. Yeah, that's right. They're all in Chicago. So in this case, A is the answer. You will choose A from drop menu on your homework. So we get the first one. Now, second one, the entire red circle is in blue circle. Red circle represents people living outside, right? Living in Chicago. So it's pretty much like all red are blue. That's a structure. All red are blue. All those people, or everybody who live in Chicago, because red means live in Chicago, likes windy days, because blue one means like windy days. So look at that. Everyone lives in Chicago like windy days. So that's B. Choose B as the answer. So it's very easy to do once you understand this structure. Now, the other two, this is the same question. I just repaste it on this page so that it's convenient for us to look at them. Same thing here. Now, let's look at the third diagram. Now, these two are totally separated. What model is that? One of those four models. You can start with blue one, you can start with red one, no difference. So if I start with blue, that means no blue or red. It means that. It's like no A or B. Or if you start with red, it becomes no red or blue. Either way, they're both true. It depends on what options we have here. Let's start with no. So there's only one thing that starts with no. No one living in Chicago, that means red. No red or blue. No red or blue. No red or blue. This one. So no one living in Chicago like windy days, which is D. So D is the answer. The last one, apparently they overlap a little bit. If they talk about this part, it becomes some red or blue, depending on what options we have. I realize that solely depend on this diagram. We read the information from diagram, then we match it to one of those statements. Or if they emphasize this part, it means some red and not blue. It depends on which part they want us to have. So let's say we have to start with sum. How many start with sum? There's only one statement start with sum. Some people live in Chicago, that means some red, like windy day, some red or blue. They are looking for this part, some red or blue. So some living in Chicago, like windy days, and that is C. Yeah, that's a C. So that's the end of the story. See you in the next video.